So we are talking about metal inspection. At around 80% of charging, you can take the sample. First, we can take the ferrolab sample, then spectro sample. As I told you, carbon in ferrolab is more consistent than spectro, but you can validate it at the initial stage of the shift, and then you can continue with the spectrometer as well. Before drawing sample, remove the slag properly. It is very important. Do not take the sample with the slag. It will give you erratic results. So before drawing the sample, you have to remove slag properly. You have to have good clean metal, and then you can take the sample to avoid wrong reading. Check bath sulfur properly. Many times we focus on carbon, silicon, and manganese and copper. We have little bit not focusing more on these elements, phosphorus and sulfur. So very carefully you have to see sulfur in ductile iron, because it can be a very important element, because based on your bath sulfur you have to decide your magnesium addition. So give focus on this element, particularly sulfur. Normally we do not give that much focus on sulfur and phosphorus in both cast iron as well as in AGI. So one has to give that entire focus on sulfur also, so that will not miss. If your sulfur is increased beyond your limit, then you have to increase the magnesium, or you to understand why it is increased. That is very important. You can increase the magnesium and you can take out that treatment is okay, but why it is increased, so that next heat you will able to control it. So it's very important to understand first that it is increased. So you have to give focus on your bath sulfur as well. Next one, magnesium treatment. As we all know, we are doing sandwich treatment. Where sandwich treatment, we have magnesium and covering. There is sandwich of magnesium and covering. Magnesium alloy, we are using normally ferrosilicon magnesium alloy. It is normally 5 to 7 or 7 to 10% people are using, or 6 to 8% also using. So there are 2-3 grades, popular grades are there, but 5 to 7 or 6 to 8 is the most popular grade, and I recommended it to use because it will give you better results. Size, as I told you, 5 to 20, but again it depends on your treatment size also. What kind of treatment, how much kg treatment you are doing, what furnace you have, what is your ladle size. All these things will also depending on your size, but the most popular size is 5 to 20. Calcium will be around 1.5%. Rare earth, that is cerium, will be around 1%. Then covering stamp will be 1 to 1.5%. It depends on your sulfur, bath sulfur, your last hit residual magnesium, your tapping temperature. There are few elements on which it is depending. You have to take a call before you decide how much covering you are going to use. You just see last hit microstructure, last hit residual magnesium, whether it is in control or not, whether it is in range or not. You see this heat particular bath sulfur, what is that, what is your tapping temperature, and based on all these three things you can decide whether you can uh, keep the same covering or you have to increase the covering. Sometimes it is better to increase covering when you are getting less recovery of magnesium alloy, maybe because of issue in the magnesium, or because of your higher temperature, or because of your higher sulfur, whatever reasons are there. When you are getting low recovery, it is always preferred or recommended to increase your covering scrap, so that magnesium treatment will get little bit delay and you will get better recovery of the magnesium alloy. While pouring the metal into the treatment ladle, make sure metal does not fall directly on alloy. This is very important. So when you increase the covering, it will also help you to delay the reaction. Metal transfer rate from furnace to treatment should be as fast as possible. I have just given one guideline here. 25 kg per second is normally what I recommended. But again, it depends on how when treatment started, how treatment started, all these things, how the when treatment will get started. Many things are uh, depending on these things. So you have to readjust your tapping temperature, tapping time, all these things. This formula we have already studied in our charge calculation sheet. I have again put up here, and based on that I have made four various calculations of magnesium. As I told you, bath sulfur will decide your magnesium recovery, and magnesium and the temperature, tapping temperature, also decide your magnesium recovery. So on based of these two, you can this is actually I have done in that magnesium recovery app, which I have given along with charge calculation. And in that I have made this auto calculations. If you change the bath sulfur, you change the tapping time, tapping temperature, you automatically get magnesium percentage and magnesium to be added directly. तो वो चीज मैंने अभी हाल ही में कर दिया है. So you can have that. This is one example. Your bath sulfur is 0.03 and tapping temperature is 1580, so high. So you have to add 1.2% of magnesium. यहाँ पर दूसरा एग्जांपल है, बाथ सल्फर कम है लेकिन टैपिंग टेम्परेचर वही है. सो यू विल लिटिल बिट रिड्यूस योर मैग्नीशियम. हियर 1.1% इज रिकमेंडेड. Third case where sulfur is low and tapping temperature is also low, so you required only 5 kg, that is 1% of magnesium. Again here sulfur is little high but tapping temperature is also high, so you also require 5.6, 1.1 kg, 1.1% of magnesium. So these are various examples I have just put up here. Then we go to metal tapping. Metal tapping temperature as per control plan. As I always say that you have to see what is your pouring temperature. So pouring temperature should be the key guideline for you while deciding tapping temperature. What should be my first box temperature, what should be my last box temperature, you can decide based on the experience that how much is the loss during the pouring. And once you go for your first box temperature, you can add around 130 degree based on your experience to get the tapping temperature. Again, it depends on many factors like what is the distance, the ladle condition, how old is your ladle, what is the tapping time you require, what is the distance you have to travel from furnace to molding line. All these things will decide your temperature loss. You have to calculate that loss. उसका भी आगे एक स्लाइड मैंने दिया है, उसमें आप अपने हिसाब से उसको चेंज कर सकते हैं. यू कैन हैव टू मेक योर ओन टेम्परेचर लॉस फॉर योर ओन ट्रीटमेंट by taking some 8 to 10 readings at various stages. तो उसको आप बना सकते हैं और इस हिसाब से आप एक बार आपको फर्स्ट बॉक्स का टेम्परेचर क्या चाहिए पता चलता है तो यू कैन डिसाइड योर टैपिंग टेम्परेचर. So take ladle in preheated condition. It's very important to reduce the tapping to reduce the temperature loss. Pre-wet metal while tapping to avoid short pour. Pre-wet का दो कारण है. You have to pre-wet metal. टैपिंग के समय वजन करना इंपॉर्टेंट है. मेटल वेट इज वेरी इंपॉर्टेंट बिकॉज नंबर वन एज आई टोल्ड यू इज अवॉइड शॉर्ट पोर. क्योंकि आप 50 kg की 5 बॉक्स पोरिंग करने वाले हैं, इसका मतलब आपको 250 किलो मुझे मेटल चाहिए जो बक्से में जाने वाला है. देयर विल बी सम स्पिलेज एज वेल. तो स्पिलेज पकड़ के आई नीड अराउंड 520 kg मेटल इन द लैडल. तो मुझे किसी भी हाल में 520 किलो लैडल में मेटल लेना है. अगर मैं प्रीवेट नहीं करके ले रहा हूँ तो मुझे पता नहीं चलेगा कि मैं 5वां बॉक्स पोर कर पाऊंगा कि नहीं पाऊंगा, बिकॉज आई डोंट हैव एग्जैक्ट आइडिया व्हाट मेटल रिमेन्स फॉर द लास्ट बॉक्स इन द लैडल. सो अगर मैं वेट करता हूँ 520 किलो है तो मुझे पता चलेगा कि आई कैन डू फिफ्थ बॉक्स पोरिंग बिकॉज आई हैव टेकन 520 kg मेटल इन द लैडल. दिस इज नंबर वन. नंबर टू वेरी वेरी इंपॉर्टेंट इज बिकॉज वी आर एडिंग मैग्नीशियम बेस्ड ऑन द metal weight in the ladle. So we are taking 520 kg, we are adding 1.1%. तो इसका मतलब है मुझे 5.3 kg मैग्नीशियम डालना है, या 500 की जो मेटल है 1% डाल रहा हूँ तो मैं 5 किलो मैग्नीशियम डाल रहा हूँ. लेकिन अगर मैंने 500 की जगह 550 किलो मेटल ले लिया तो इट विल गो टू 0.9, दैट इज 0.9%. तो 8% के हिसाब से मैं डाल रहा हूँ लेकिन मेटल ज़्यादा लेने की वजह से इट विल बी 0.9% नाउ, एंड देन I will not get the desired residual magnesium. It may get लास्ट फ्यू बॉक्स नोडलिटीज विल बी लोअर साइड, मुझे वो नोडलिटी कम मिलेगी बिकॉज द मैग्नीशियम परसेंटेज विल गेट रिड्यूस। तो एक ये भी चांसेस है, सो दैट वी हैव टू प्रीवेट द मेटल while tapping. This is very important. Then put cerawool cover on the ladle to reduce temperature loss, temperature drop या temperature loss कम करने के लिए cerawool डालना important है। This is what I was talking about। आपका जो बाथ का मेटल है वो आपको पता होना चाहिए कि मुझे बाथ में फर्स्ट बॉक्स के लिए कितना टेम्परेचर चाहिए। देन बाथ में कितना मेटल चाहिए उसके लिए आपको फर्स्ट बॉक्स का टेम्परेचर पता होना चाहिए। यहाँ पर मैंने दिया है कि ऊपर से नीचे से आप देखेंगे तो 1400 इज द टेम्परेचर फॉर द लास्ट बॉक्स। द लॉस ड्यूरिंग 6 minutes of pouring will be around 30 degree because I am pouring 6 minutes and my loss is around 5 degree per minute with the cerawool. So 1430 will be my first box temperature. So you have to calculate these things: temperature loss in treatment and temperature loss during the transport. So you can get that particular loss in your own foundry. This is what I have calculated in our foundry. You have to calculate in your foundry what is that particular loss, because it will differ from foundry to foundry because of ladle condition, because of distance, because of tapping time, and many other factors. So you have to calculate it, but normally it will be around 110 to 130 degree. We can say that will not much differ much in foundry to foundry base also. So you have to check it and work it accordingly. Next thing is inoculation. Inoculation practice is very important in ductile iron because the better is the inoculation, as I told you, will be the good nodal count, good ferritic structure, good machinability. So primary stage inoculation practice from furnace to treatment ladle is very important. Secondary inoculation, treatment ladle to pouring ladle. So both is very important. So furnace to treatment ladle and then secondary treatment ladle to pouring ladle. Normally primary plus secondary should be 0.4 to 0.5% as a thumb rule. You can divide it in two or you can put it as a single in one or any of the case. So it depends again on how you tap, how you transfer the metal, what is the distance, and it depend on your practice of the pouring. आप प्राइमरी स्टेज में डाल सकते हो, सेकेंडरी है तो सेकेंडरी में डाल सकते हो. So you have to combinedly use 0.4 to 0.5% of inoculation. Stream inoculation is another way, that is while pouring from pouring ladle to mold, you can put it. For ferritic grade, it can be used more predominantly because of it will give you good ferritic structure, good ferritic matrix. So stream inoculation is important in ferritic structure mainly. Mold inoculation some people are using, but in India it is not much popular thing. Pouring practice, pour metal as low as possible to avoid sand erosion. जितना आप नीचे से pouring करोगे अच्छा है. Pour within 5 to 6 minutes to have better inoculation effect and good nodulity. Remove slack from metal at various stages, from furnace to tapping, then to the treatment ladle, from treatment ladle to pouring ladle, and in the pouring ladle as well you have to put some slack coagulant so that the whatever slag is generated will remain floated. Pouring practices: take spectro sample at last box of each sheet, take micro coupon at last box of last box to check nodulity is very important. Pour test bar at stipulated time frame as per as your control plan for each grade. Ensure enough metal available before pouring last box. This is very important again, that you have to ensure that adequate metal is available in the ladle so that you will avoid short pour. Ignite gas while pouring. Measure pouring temperature for second and second last box. Knockout practice. Cooling time should be 45 to 75 minutes after pouring based on your grade. As I told you, for ferritic it should be 75 minutes or more than 60 minutes we can say. For perlitic grade it should be 45 minutes. For ferritic perlitic you can go between 45 to 60 minutes. So it depends on the grade and your section thickness and the requirement of your matrix and hardness. Remove pins after 25 minutes after pouring. Do not remove pin as soon as you pour the metal. Wait for 20 minutes, at least 20 to 25 minutes before you remove the pins. Remove clamps after around 30 minutes after the pouring. Note down first box, last box, pouring temperature and pouring time. Knockout time for each heat has to be maintained for the traceability, and note down collect metal spillage from each box before knockout to avoid spillage get mixed up with sand plant. It's very important that you have to uh, take out the spillage from the box after pouring with the magnet, so that it will not be get mixed up with the your sand. It will not go into your mixer. Sandwich treatment is done for magnesium treatment. It is known as sandwich method. As I already told you, magnesium 0.9 to 1.2% normally, normal range we are using at the moment. Covering punching 1.5 to 2.5, again depending on various factors. Poking is very important. Poke properly after you put a magnesium as well as you put covering punching. Use twin dish cover to avoid the oxidation loss and the magnesium, to improve the magnesium recovery. Also, it helps you in reducing the temperature loss. Magnesium reacts with oxygen and sulfur. So magnesium oxide and MgO1, MgS are the two factors. That is, we can say slag or dross are produced. As I told you, magnesium is in this slide you can see magnesium is a lighter material, so it try to float on the metal surface. So it tends to float on metal surface. That is why it is more in contact with oxygen. So recovery of magnesium is less. So to increase the recovery, wherever possible, you use covers, cover of ceramol, cover of twin dish, so that your magnesium recovery will be higher. Magnesium will not come in contact with oxygen, and your magnesium recovery will get increased. This is how the time slot, with the time nodulity goes down, as well as inoculation effect also goes down. This is a very important slide. The this will guide you when your nodulity get affected, when you have to add more magnesium and when you have to add less magnesium. So control your addition of magnesium alloy. You have to follow these particular guidelines. Number one is the sulfur content. If you see that if sulfur is less, then your magnesium alloy will be less. Sulfur is high, then your magnesium alloy is addition will be always high. Second thing is tapping temperature. Tapping temperature, less is the tapping temperature, your addition of magnesium alloy will be less. Higher is the tapping temperature, magnesium alloy will go up. Number three is a slag. More is a slag, or you can say clean is the furnace, your magnesium alloy addition will be less. And with the increase in slag or sluggish condition in the in the furnace, your magnesium percentage, alloy percentage will go up. The time between magnesium alloy addition and tapping. This is what is happening many times. We take the bath sample, and once we take the bath sample, the person who is the pouring person, the operator, suddenly puts the magnesium inside the ladle, and then we are come to know that there is some issue in the chemistry. Either carbon is up, carbon is low, or manganese is up. Something is there in the chemistry, and we have to rearrange that chemistry, and it will take some 5 minutes. So till that time, whatever magnesium is put in the ladle, that will start get burning. So the time between magnesium alloy addition and tapping should be minimum. It should not be more than 30 seconds or 45 seconds. So once you are ready for tapping, when you confirm that my chemistry is okay and my temperature is just to reach tapping temperature, you just give a call to the person that you put a magnesium. Till that time, he has to wait for your concern that you are your call, and he has to wait for your thing that you have to add the magnesium. So this is very important. Many times it happens, unfortunately, and we lost the magnesium recovery. So this is very important. Next thing is alloy covering. So I told you that alloy covering, that is covering punching. If it also depends on the quality of punching itself, how much has to be added. If the punching is lighter in weight, it is lighter in thickness, you have to add little more because it will get melted fast. It will be lighter material, then it will get melted fast, so you have to add little more percentage of material inside the ladle. So again I just like to remind you, the alloy covering, that is covering punching, is depending on your tapping temperature, your bath sulfur, your last heat magnesium, residual magnesium, and also your covering quality, covering punching quality. So if the quality of covering punching is good, you have to add less magnesium. If quality of covering punching is bad, you have to add more magnesium. So this is very important again. Ladle design, I will say it is a common factor, so I will not go into detail of that because normally we have using the same ladle. As I told you, ladle design, it should be 1:3. One The height to diameter ratio, it should diameter to height ratio should be 1:3. So diameter is 1, then your height should be 3. It is between 1:2 and 1:3, somewhere between, but that is a constant factor, so I'm not going to detail on that. Then your chemical composition of alloy, that is magnesium, ferrosilicon magnesium. If the rare earth and calcium percentage is good maintained, that is calcium around 1.5 to 2%, and rare earth around 1.5%, then your magnesium addition percentage will go down. If the calcium and rare earth percentage are less, then your magnesium addition will go up. So you have to select a good magnesium alloy with good calcium and good rare earth, so that it will help you in reducing your addition. And last but not least, the oxidized magnesium alloy. Oxidized magnesium alloy, it means you keep magnesium in open air, or magnesium get wet because of rain or water, whatever is there, it get oxidized. Once it is coming in the contact with air, it will start getting oxidized. So oxidized magnesium alloy always give you a low recovery. So if you have an oxidized magnesium alloy, then you have to add more magnesium. If you have a good magnesium alloy, fresh magnesium alloy, it is well packed, packed and well kept in a good packed container, then you have to you can reduce your magnesium alloy percentage. So this is very important. Residual magnesium and magnesium recovery has always been subject for discussion. As I, was discussing with you, various factors are there, and we can see one by one all those points once again. The sulfur content in the base metal is one of the factor. If your sulfur is low, then definitely your magnesium alloy percentage will be less. If sulfur is high, you have to increase your magnesium alloy. Number two, oxygen content in the base metal. If you have superheated metal or hold up the metal because of any reason, because of molds are not ready, breakdown is there, or you have to adjust your composition, whatever reasons may be, then if your metal is wetting, then the oxygen content in the metal will go on increasing, and then definitely you have to increase your magnesium alloy. This also causes to your magnesium failure and nodulative failure. Next thing is slag from the melting or holding furnaces. The slag, as slag is more, your magnesium recovery will be less. Tapping temperature. You have to keep tapping temperature as low as possible so that you can have less uh, magnesium burning. You will get more recovery of magnesium, but for that you have to control your losses during the transport of metal from treatment to ladle, then ladle to pouring ladle. You have to keep some kind of covering like ceral cover or twin dish cover or something like that, so that you can reduce your losses. That is the only way. You cannot reduce the tapping temperature unless until you do all these things. So try to optimize your tapping temperature. Do not take excess tapping temperature. Work on the optimization of tapping temperature to reduce your magnesium alloy addition. This is very, very important. Next thing is time between magnesium addition and lateral tapping. As I told you, is very important. Keep eye on the person who is putting a magnesium. Give him a call that now metal is ready. Tapping temperature is just to arrive and put the magnesium. Unless and until you give that call, he doesn't allow to add that. It's very important. Slag in ladle and pocket, as I told you, slag in the pocket will also cause a problem, because if pocket is sluggish and it contains the slag, then your magnesium and covering punching will not fill properly, and sometimes it comes out of the pocket, and then your reaction will start early, will not get desired magnesium recovery. So you have to take care of that, that your pocket should be always in good condition, slag free, and free from slag and other material, or even sometimes some metal is also there in the pocket. It is also, I have seen and experienced in my uh, career, that sometimes there is some metal inside the pocket, and because of that, what happen, whenever you put the magnesium inside, it will start burning little early, and your magnesium recovery get affected. Also, it helps you in breathing of alloys. Sometimes metal inside the pocket will help to breeze alloy, that metal and covering punching together, and then you will not able to get proper reaction, and whatever metal is you are pouring is not properly mixed up with the magnesium alloy, and that whole metal or whole dynamo get converted into very bad quality of bad quality of metal. So you have to take care that there is no slag, there is no material, there is no metal inside the pocket. Next thing is alloy covering. As I told you, alloy covering is very important. The quality of alloys, quality of covering punching is also important. Next is filling time, that is the tapping time. Tapping time you have to control. It again depends on foundry to foundry, depend on your foundry practice. Fading and pouring time, you have to have a buzzer. When you start the tapping, you have to push the button, and within 7 minutes or 6 minutes, whatever stipulated time you have decided, before that you have to finish the pouring, and at the end of the pouring you have to take sample for spectro and for the micro. You are not allowed to go beyond the stipulated time, because it will not guarantee you the good quality of ductile iron material. You may fail in the microstructure or nodulity. So it is very strictly to be followed. Inoculation. With a good inoculation, less residual magnesium is required. This is very important, because inoculation practice is very important. The best inoculation practice is to start after around 25% of metal gets into ladle. You start the inoculation, and you finish the inoculation before last 25% of the metal remaining in the furnace or ladle. So in between 50% of metal, you have to finish your inoculation. The inoculation should be on the stream of the metal. So this is the best inoculation practice. If you do it like that, and your inoculation quality is good, then definitely you will have a good nodulity, you have a good machinability, you should have a good nodal count, and you will get good metal quality. Ladle design, as I told you, 2:1 or 3:1 should be the ratio. Will not go in detail because it is a constant factor. Chemical composition of nodalizer, that is the magnesium alloy. As I told you, cerium, that is the rare earth, and calcium are the two important factors. Calcium helps you in reducing the reactivity and suppress the reaction. So calcium is very important, and rare earth helps you in arresting some of the element which are harmful to you. So cerium is also very important. Also, it promotes the nodulity to some extent. So calcium and cerium are two important factors here. Next slide, there is alloy sizing. Size of alloy, as I told you, 5 to 15, 5 to 20 or 5 to 15 are the two more popular sizes. Storage of foundry alloy. This is again important to avoid the oxidation of magnesium alloy, you have to store it in proper uh, containers which are sealed, or in bags which are sealed. These are the ladle design, we can say. The treatment ladle pocket, you have to use charging panel to add the magnesium so that it will drop into the pocket directly. It will not get segregated here and there. Then how the ladle should be filled, you have to pour the metal in the pocket which is empty. That has to be strictly followed. You have to adjust your twin dish cover so that your metal get fall into the empty pocket. It will not go into the pocket where the alloy is there. This is the revolution, you can say, for the magnesium alloy percentage. Very old days when I have started actually in 1994, it was around 2% we were using at that time, because there was no spectrometers available. The raw material inspection was not that strict. The control on raw materials were not that stringent. So sulfur and manganese, everything was not known to us when we get the material. So we were using around 2%, but with the raw material inspection improved, the control on tapping temperature improved, the pocket design improved, the sandwich method improved, the twin dish cover comes in, the spectrometers comes out. Now we can use between zero point 0.9 to 1.2% of magnesium. So this is the revolution, we can say. This is another chart. Last time during LCAM, the suggestion was regarding the various element. What should be the limit, then sources, and the effect on various things like whether it is ferritic perlite, ferritic promoter, or perlitic promoter, or carbide promoter, whether it reduces the chill, whether it helps in BH and pinholes, whether it helps in nodularity improvement, good or bad. All these things are been put in one chart by me. I think it will be a very helpful document to everybody. It will definitely help you in understanding the effect of each element, their limit, and I think one such sheet in your lab will help you in long term. Slogans, as I told you, always prefer CRC. Do not add carbon at the end. Keep CRC aside to maintain carbon percentage. Every transfer point remove slag and add inoculation. Microstructure, by adding zero point 0.2 to zero point 0.8 copper, we can improve the percentage of perlite. As I told you, the copper is almost very important because it doesn't give you carbide. It is a perlite promoter, and it gives a good stability. So it perlite grades, you more prefer the copper percentage. Tin, as I told you, it is not good. Tensile strength, everybody will know that in manganese we have to control zero point 0.2 to get 400 by 15 grade necessary properties. Strict control on scrap selection is required there to get ferritic structure. Higher grade stress relieving is recommended for casting specification as well. Nodularity, final sulfur should not be more than 0.02. Retail magnesium should not be more than 0.04. I have almost covered all this point. I think during my slide it is again repetition, we can say. So I will just go ahead. This is one slide, ductile and microstructure. The percentage and nodulity I have shared here for your ready reference. Process control in magnesium in ductile ion. I think we are just 3 minutes short, so we'll do one thing. We'll have a break again.